quite a bit larger. The challenge was, is how to fill the vision of that director and make it believable. Seriously pushing the limits of what we had on our render farm. The end result that you see here, everything that you see is completely digital. The water, the waves, the splashes, and of course the largest model ever built at Island at that time. This is simulating millions of gallons of water in a boat 1,100 feet long. It's huge. Fast forward a little bit to 2006, when director Gore Verbinski had a vision for the Pirates 2 of this thing called the Maelstrom. The Maelstrom was going to be this huge whirlpool of water, and it was going to be just a massive part of the film, about a 15-minute segment part of the film. Now what was key here is it was taking 5 minutes to sim each of the water shots. Not too bad. But on top of that, you had to add bubbles, sprays, flashes, the ship weight, and render all the other elements in there, and it took upwards of 20 hours per frame to render. The final result, pretty convincing, but it's just let me show you what it looks like. So anywhere that savings could be done in the visualization process had huge ramifications across the facility. And that's what leads us to where we're at today with what's going on with our GPU work. So you have to understand as to how big these things mean to us. We have a project that we kicked off a few months back with Project GPU. The goal was simply to use the GPU wherever possible to help speed up these simulations so that the techniques for production could be much improved in the visualization that the directors wanted to get, to be something that they could work with almost interactively if possible. That was the challenge. Set some objectives. Give faster iteration time for the artists. Increase the speed with which things could be put through the system. Be able to handle much larger data sets. And be forward-looking in the architecture. And of course, because we are a facility that works for hire at ILM, always positive cost benefit. Let me show you some of the research examples that we've had using the GPU. Now, the things you're going to see here are completely GPU done. So the first one. Pretty impressive. Let me show that to you again. Give you some stats on it. This is over 12,000 rigid bodies. This took an hour and 13 minutes on one computer using the GPU card. Didn't even touch all that farm. Then this tests continue. Again, with some stats for you. Over 100,000 rigid bodies. Okay, this took 3 hours and 20 minutes, a little longer. But keep in mind, up to this point, the most that we had ever simmed is over 14,000, just over 14,000 rigid bodies, and that was across multiple machines. We're doing this on one machine with one GPU. Huge impact to the facility that this is happening. And like I said, we don't do things just for the sake of technology. We started to experiment what we could do with some models from the film that we were working on. Hang on one second there. I think we just jumped a little too fast. We get to see the big destroyer. We're all done this morning. Now that visualization enabled us to use this in a film, and that film is Transformers 2. where one of the main scenes at the end has Devastator tearing up the top of a pyramid here. Okay, so this was able to give the director a great visualization of what the simulation would look like and how it would perform so you could work under camera moves. And here's what the final scene looks like. And you'll note the blue lines above and below. Things that are rendered above and below that are the IMAX. Because not only are they pushing the limits of what we can do with simulation, they're pushing the boundaries of how much we can render as well. But a great way to give some visualization to the director and understanding of what was taking place with that film shot. And very happy with it. But we didn't stop there. So rigid body simulation was an area. But what about fluids? So what we started to do is experiment with what kinds of fluid dynamics could be done using the GPU. And we started off with fire. And again, because nothing is done for the sake of just checking out technology, this actually got put into a film. What I thought would be a great idea for so many developers of you that are here is to hear from the artist who worked on this film, and he'll take you through the steps of what was done with this fire and how it was put into the feature film in Harry Potter. With that, I'd like to introduce Chris Horvath.